Okay, so hello and welcome everybody to yet another OpenShift Commons briefing. This time we have a new OpenShift Commons member, Prophetstor, who's going to do a talk on AIOps on OpenShift and doing autoscaling and predictive, all kinds of goodness. They did a small, very short talk at the OpenShift on machine learning special interest group about a month ago. And it clearly wasn't enough time, so we're really grateful to have Jeremy Way and Brian Plank back from that talk to do a deeper dive into what they're doing. And hopefully we can have a conversation at the end with some live Q&A and get some more questions answered and figure out where we can collaborate and with them a little bit further. So without too much further ado, the way that we do these briefings is if you have questions, ask them in the chat. We'll try and answer them, and at the end of the presentation and the demo, we will unmute some of the folks who ask the questions and let them ask them live and have some Q&A at the end. But without any further ado, Jeremy, could you introduce yourselves and start us off today?
Sure, of course. Thank you, Diane. My name is Jeremy Way, the VP of the Corporate Development Prophetstor. And today I will introduce the Prophetstor AIOps technology and give you the demo how we can help OpenShift users and automate the scaling and the scaling for the Kubernetes environment. And my colleague Brian was assisting me for making the demo. Brian?
Hi, I'm Brian. I'm just like Jeremy introduced, we are going to have a demo of our AIOps platform. And especially we are going to demo about how we use AI for Kubernetes to do the path scheduler and also path autoscaling by using our artificial intelligence technology.
Okay, thank you, Brian. And first of all, I would like to introduce the company. And Prophetstor was founded in the year 2012, located in Milpitas, California. And after today, we have over 110 employees, 7 branches in APAC and EMEA. And since the first day the company was founded, and we dedicated bringing artificial intelligence to the IT operation. In the past 60 years, we already granted over 15 patents. All of them are the cornerstone of the AI technologies, such as the container deployment, operation automation, and some the performance optimization, text health model prediction, and the data center automation, and so on. And we will also give you the more details about our technologies. And the Prophetstor not only provides insights, but also foresight. I think that on the slide, you can see the 4 versatile features we provide to users. And first of all, we can predict the error and failures with a high accuracy. The average accuracy is over 95%. And we also predict the future demands for the compute resources for each applications, as well as the performance degradation caused by any future demands. And we also detect and predict anomalies and predict what kind of impacts on your applications if any instance of or events that occur in the future. So for example, and how much percentage of the performance will be lost if any disk or memory the error occurs. And we can provide the more foresight for the end users. So users can get a clear picture and plan ahead. And as you know, in the cloud native environment, a pod is just a pod, and a pod has no intelligence. But OpenShift provides a programmatic intelligence for users to manually create a resource request. And however, those resource requests are just a wish list without guarantee. So the users always overcommit or over-provision the resources to fulfill the request. So the over-provisioning becomes the most popular practice in the industry. It's such a big waste. Even though the over-provision were planned, there's still no guarantee to meet the future demands for the request made by the end users, because there's no visibility infrastructure health and no the resource availability that actually demands. But what if we can't predict how many resources will be available and how many resources will be actually needed in the future? And then we can elastically provision resources with a better SLA, and the machine learning can make it happen and dynamically generate optimal solutions to meet all future demands for the path scaling and the scheduling. And so on this slide, you can see Prophetstor AIOps, and it's a microservice running on the control path and has no impact on the data path. And it serves as extension to the OpenShift and the Kubernetes. On the right side, you can see how the Prophetstor AIOps technology works. And first of all, the operator can learn the continually change demands in the cluster. And then you can plan the resource allocation for all paths by using predictive analytics, including capacity, performance, anomalies, failure, and so on. And last, the operator executes the plan accordingly, works with the OpenShift scaler and the scheduler to orchestrate container to eliminate the noise neighbors and ensure the better SLA. So Federator.ai is the Prophetstor AIOps function, it's our name, and which to collect the data from the underneath the Kubernetes clusters and feed it to our prediction engine. And the prediction engine will generate intelligence for the path resource allocation to meet the future demands. So the user can get a clear picture. They can manually to execute the plan, or we can set it to auto. And last, if you set it auto, that the operator can execute a plan to support autonomous scaling and scheduling. On next slide, I will give you the more details. So first of all, our data collectors can learn continue to change the demands from the cluster and feed it to the prediction engine on the right. And then the prediction engine will generate the prediction for the future demands, including including compute resources and the future events. And the last, we provide this kind of intelligence to the operator. The operator will execute the plan accordingly for the path resource allocation, and as well as send an alert to the users if any future event is predicted. So you can see by using Federator.ai, using these less resources, this less hardware, less cost, and less time for the configuration. So next, we are going to give you a live demo. We will showcase 3 demo scenarios. And first of all, we will demonstrate how we analyze the computer metrics across the multiple nodes, and then plan the node allocation by using the AI technologies. And the second demo scenario will showcase how we predict the future demands for the path scaling by using AI. And the last one, we will show you how the Federator.ai predicts the instance and predict what kind of impact on the cluster. And we will take the Ceph and OSD failure as example. And now I will hand it over to the Brian. Brian. Okay, go ahead.
Okay. In this demo configuration, we use a very simple, purposely simplified configuration. It includes 4 physical nodes. The reason why we use physical node, because we at the third demo, we also want to show how we use artificial intelligence to predict this failure, and to show how we use AI to predict the impact of this failure. Then back to the configuration explanation. And there's a one master node of OpenShift, Kubernetes, and the 3 worker node. And the underlying storage is Ceph. And actually, it is the Ceph is operated by Rook. Okay. Jeremy, please go to the next slide. Okay. The first demo scenario is about using artificial intelligence to automate the path scheduler. The reason why we want to use artificial intelligence, there are mainly 3 reasons. The first is we know that in a larger environment, maybe 100 or thousands of paths, it's very hard for IT administrator to configure each path correctly, just match the just provision required resources. So IT administrator usually need to over provisioning CPU and memories, and actually it is very waste. It wastes a lot of computing resource, and if the system is hosted on AWS, each EC2 costs money. So our idea is to use artificial intelligence to predict performance of path and performance of node, and to decide which path should assign to which node. So the second reason is that we want to bring efficiency, operational efficiency for IT admins. Of course, the third reason why we use artificial intelligence is we can help the enterprise or data centers to reduce the total cost of operating Kubernetes and OpenShift. So next slide, please. Okay, this is the screenshot of the view that shows how the performance we collect from Prometheus of each node. Just as I mentioned before, in this configuration, there are 3 worker nodes. So in the top of the screen, we can see there is a list box with 3 nodes. And Jeremy, please click your slide. Yes. So there are 3 nodes, and the CPU, the current CPU usage shown within the red box is the CPU loading we collect, the Federator.ai collected from Prometheus. So we can notice that there is an imbalance of CPU usage across the 3 nodes cluster. In one node, there's a very high CPU usage, and the other 2 just have too low CPU usage. So we can expect that maybe in the highest loading node, if there is any part that have accidentally high loading, that may exceed some threshold set by IT administrator. So what we are going to apply artificial intelligence is to predict the performance metrics, especially CPU in this case. So in the underlying part, this chart shows the historical CPU usage and also the predicted CPU usage. And the 3 nodes are in different colors. So the darkened line represent that the CPU usage is higher, and lighter color represent that CPU usage is lower. And the left part with dashed lines are the predictive performance metrics. The technology we use to predict performance metrics is deep neural network. The reason why we choose deep neural network because there's one specific algorithm called LSTM. I won't go detail about this algorithm, but we enhance this algorithm to especially design for modeling time series data of performance metrics. So our AI engine now have 2 types of information. The first is the performance metrics of each node, and the second type is the performance metrics of each part. So we use a time series clustering algorithm to categorize the performance metrics of each of the paths and of the nodes, and then use some what we call balancing algorithm to balance the performance metrics of each node. So now you can see there is one chart added at the bottom of this screen. This shows the result of our AI engine generated. Again, in the left right part is our prediction about what will happen if user apply our recommendation. So the total benefit of this approach of this method is now the CPU load usage on each node is now leveling. So there are several benefits. The first is user don't need to worry about one generate higher performance prediction accidentally. So the whole system can operate more stable. And the second benefit is that user can assign more node paths to each node. So the whole cluster can have more loading and then save more cost. And all of this kind of our path scheduler is based on prediction, not just based on current value. So the user don't need to worry about they just get the foresight of what was going on in the future. So the CPU usage will become more balanced across the multiple nodes. And then, okay, then next I will just go to our Federator.ai dashboard to show a live demo. Okay, I'm going to share my screen. Okay, can you see the dashboard, Jeremy?
Yeah, we can see you.
Yeah, we can see
Okay. Okay, thank you. This is the dashboard of our Federator.ai. The left part is the menu selection, and one of the unique concept of Federator is we provide the cross-layer insight and the foresight. I'm not going to describe all of the features here today. I'm just focused on Kubernetes. Maybe there's more time. Next time we can demo other parts of Federator.ai. So I'll go directly to the Kubernetes menu and then go to the path allocation. Okay, now this is the same system that's just shown in the PowerPoint before. And again, there are three nodes here. And this is the CPU usage. This is a very stable system. And again, here in the lower part is the historical CPU usage. And in the right part of this chart is our prediction. So now I'm going to enable AI planning. And after I click this AI planning button, our AI engine will generate the performance prediction based on historical data in the left part. And also generate is a recommended path allocation plan for users. So now you can see in the underlying part, the AI engine generates its recommendation for these three nodes based on all of the paths running within these three nodes. So just as similar to the screenshot in the PPT. Now we have very leveling CPU usage of the three nodes. And of course, today I just demo the planning, but there's one button here that is SQ AI planning. So this means when user click this button, our AI engine will take care of the path allocation operation for users. And this feature is not finished yet. So there's no demo for this feature today. Okay, then I will go back to the second demo scenario. I will start sharing first. Okay. Jeremy, would you please help me to bring the PowerPoint again? Okay, thank you. Then the second demo scenario is the vertical part autoscaler by artificial intelligence. Just you already know that it means we will use artificial intelligence to automate. To plan the part resource configuration first, and then user can base on this planning to automate the part configuration continuously. The reason why we want to use artificial intelligence to provide this resource configuration automation and planning is that we know that part is very dynamic. And of course, workload are also very dynamic. And the current vertical part autoscaler provided by Kubernetes only can adapt to the current metrics. So users don't have the foresight to know in advance what might going on in the future of all the parts. So there may be some scenario that they oversubscribe more computer resources for parts, or they may under subscription. I think neither of these two issues are good for Kubernetes operation. So so by using artificial intelligence, then we can use the predictive computing resources and apply those prediction to the part configuration. Okay, then this is the screenshot of the part resource configuration view. At the top, here is a part list. Again, we get the information from OpenShift. And then at the bottom is the CPU utilization of the first part selected by us. And in the left part of the screen, here is the current part controller CPU configuration. You might be wondering why this is in percentage. That's because we convert the mini to convert the mini core value to a percentage of the nodes it runs. So it helps user to easier to understand the loading of the parts. And then that part is our prediction for this part running on this node. And at the top of this chart is our recommended part controller CPU configuration. So the way user can use this kind of prediction is that we will continuously generate this kind of prediction based on historical data in a certain interval. So one way is user can delegate this work to Federator.ai, and Federator.ai will take care of the CPU configuration via part controller API, or they can just get the recommendation by our engine and do the configuration by their own. And in the one thing I want to mention is that in the underline part, you can see there are 3 lines. The center line is the prediction value, and the top and the bottom line are upper bound and the lower bound of the prediction respectively. And so we are not only predict CPU usage, we also predict on memory utilization. And again, in the left part is the historic data and the current part controller configuration. And in the right part is the predicted memory usage and also our recommended memory configuration. And one thing I want to mention is that in today's demo, we only show a CPU and a memory prediction, but actually we can apply it. We can predict on different kinds of metrics. For example, if there is a custom matrix about the disk I/O, maybe LPS, throughput latency, or network traffic, then Federator.ai will provide the same kind of prediction capability. Okay, now I'm back to the dashboard again. And this time I'm going to go to the power resource. Okay, I'm going to log in again because my session is ended. Okay, I will go to the Kubernetes and then select the power resources. And here is the same configuration of same as the screenshot. And I will select the first part here. So you can see there is the performance prediction about the CPU utilization here. In the left part is the historical data, and the right part is the performance prediction, the prediction of the CPU utilization. And you can also select the memory utilization, so it will show the memory prediction. We doesn't only provide the now the screen show the 1 day, the next day, next 24-hour memory prediction, and we also provide middle term prediction and also a long term prediction if historical data have enough amount of data. So again, here is the historical, the current configuration of memory, and based on our prediction, our AI engine will suggest the predicted request and also limit memory configuration. So by using this AI, the user don't have to configure compute resources of CPU and memory by their own. They can do the planning based on, they can rely on our planning and do the conversion by themselves, or they can click this button to execute AI planning and also execution. Then our AI, our Federator.ai will take care of the configuration for users. Okay, this is end of the second demo scenario. And we'll go back to the third demo scenario. I'll stop sharing. And okay, thank you, Jenny. Then the third demo scenario is different from the first two demo scenarios. This one is about we using artificial intelligence to predict disk failure on storage. Especially in this demo, we use Ceph. The reason why we use Ceph, the first reason, of course, is since we are using Rook, so we use Ceph as underlying storage. And another more important reason is that we think Ceph is a very good storage choice for containers, but the Ceph has a problem that when its data disk is lost, then since it's a distributed storage, so data need to be rebalanced across all of the Ceph cluster, and under this data rebalance period, there will be a performance degradation across all of the Ceph cluster, maybe 35% to maybe 50% of performance degradation to the whole cluster. So we think it's a good idea to use artificial intelligence to help IT administrator to get this failure prediction in advance of their failure actually happen. Okay, here is the dashboard and the screen of the disk of the demo, of this demo. And again, in the top part is the part list of all these Kubernetes OpenShift cluster. And in the bottom top is a correlation map. This correlation map is we built the relationships of all of the objects in different layers and provide a very useful view to help user to see how their services of Kubernetes are connected to this path and also connected to the persistent volumes and also connected to the underlying storage. So in this the demo, we use Ceph. So there are 3 OSD here, and each OSD is connected to a disk. And this persistent volume is provisioned to this work path 1 part, and this upper service at the top. And you can notice in this impact, in this correlation path, correlation map, there is a disk that in red. This means our AI engine predicts that this disk is going to fail within next 2 weeks. Our AI engine gets the smart data of each disk, and those disks can be hard disk, hard drives, spindle disk, or SSD. And we generate prediction about the health status of the disk. So by using this correlation map, user can easily find that if this disk actually fail, then you will impact the OSD 0 and impact its performance. Impact its persistent volume and impact this part. You can find the impact path by tracing these red lines. And Jeremy, would you please go to the next? Yes. Yeah, thank you. And one very special feature of this failure prediction is we doesn't not only show the disk failure prediction, we also provide information about the performance degradation. So here you can see from this in this persistent volume icon here, there is a performance degradation about 21 and 7% of performance degradation if this disk fails. And this performance degradation prediction is based on the performance matrix of this disk our agent collect. So user can base this performance degradation of maybe there are several disks that our AI engine predict going to fail, and user can decide based on this impact map which disk they need to take care first. So by using this feature, we try to correlate the storage to the pod operation. Okay, then I would go to the live demo. Okay, then I will go to the Kubernetes part here. Okay, then here is here is the pod list here, and we select the first part, and in the underlying part is the information about each part, and here is the impact map of related to this part. You can see almost the same screen of the screenshot, and you can notice there is this disk we predict is going to fail, and this fail will impact the OS 0 and impact this PVC, I mean this persistent volume, and then impact this workload, and at the end it will impact the topmost service. And I will zoom in a little bit, and you can see the performance degradation information here. Of course, in a large system, there will be more persistent volumes than only this one, and user can also switch to the host view. In the previous view, I showed a part view, and here I now go to the host view. And in the impact host view of the impact map, it show all of the persistent volume and paths that relate to this host. So in a large system, user can use the path view and host view to see the underlying infrastructure problem and how the possible problems will impact the operation of the paths. Then this ends my third demo about the disk failure prediction and also the impact prediction. Okay, I will stop sharing again. So, Jeremy, would you please bring the presentation if you can?
Jeremy, yeah, there you go.
Okay, and another feature we doesn't demo here today is about the modeling of the future demands. We can image that maybe there is some situation that we already know in advance that there are some high loading due to the holiday season, and user want to know if their current computing resources are enough to handle those special loading requests. So we are going to provide a feature we call what if modeling tool to let user provide those loading input, and our AI engine will tell users if their current nodes or CPU and memory of those are enough. So this is the I think this is very useful for Kubernetes and OpenShift operation. Okay, and then and then this ends the 3 demo scenario. The first is the path scheduler by using artificial intelligence, and the second is the vertical path auto-scaling. That means to use the performance prediction to help user to understand recommended computing resources. And the third scenario is about predict the underlying hardware issue. In this info, we show the disk failure prediction and how it will impact the persistent volume and also the paths. Okay, thank you.
All right, thank you, Brian. That was very interesting, and there's a couple of questions in the chat. If you want to just put your last, keep that slide up while we're asking the Q&A. It's good so people know how to get a hold of you. One of my questions was about how you're loading the historical log files to use as training data for your models. I'm wondering if you could talk a little bit about how you load and create your training models for this.
Yes. Of course, the historical data we get is from Prometheus, and we feed those historical data into our prediction engine. And in this prediction engine, we have several deep neural network algorithms, especially those for used for time series data prediction. And then the performance prediction will then generated from those trend data based on the historical data. And since this is about the performance prediction, so our AI engine will continuously update its train model if there is a large, if our system detect it's necessary to retrain the prediction models. And so this is the best flow of our prediction model. And for the hardware prediction model is a little bit different, especially for the disk failure case. We have some pre-built, pre-trained disk failure prediction model into Federator.ai. Those prediction train model are used for generate disk health prediction for both spindle disk and flash disks. And then our AI engine will output the healthy prediction of disks in 3 different color flags, green, yellow, and red. For the green, it means the disk, you don't need to worry about disk failure within the next 6 weeks. And if it is in red, that means the disk will highly possibility that going to fail within the next 2 weeks. And this is about the 2 different prediction model used for time series data and for disk sensor data.
Perfect. I think that bleeds right into the next question. Juana was asking about more information on the prediction model. Juana, did that answer your question? And if not, can you unmute yourself and ask another follow-up on that?
Hey, Diana, yes, I just wanted to have more information on what prediction models you use. Is that proprietary or is it open source or?
Yes, it's a proprietary algorithm. Of course, we base on some well-known algorithm. Basically, it's about the recurrent neural network, and then we modify the algorithm for our AIOps purpose. And for this failure prediction, it's also based on recurrent neural network, but there's a lot of modification to this algorithm because the smart data, especially smart data of disk, have very different characteristics than other data.
So I think that probably answers your question, Juana. If there's other questions, people, please feel free to type into the chat and ask. Otherwise, I'm going to keep asking questions. I'm curious, Jeremy, if and Brian, if you're running your platform on OpenShift Kubernetes by any chance. So if you're doing your training and this whole thing is running on top of Kubernetes.
Yeah, the current the demo is related to the running on top of the Kubernetes, the OpenShift. It's the service as a microservice in the OpenShift.
I thought maybe. So that's great to know. It's very this whole thing is really interesting to me. I don't know if there's anybody else from the OpenShift Online or OpenShift dedicated team who are watching here, but have almost 3 years worth of log files and data from hosting OpenShift Online. It would be really interesting to see some of this predictive stuff run on some of our folks, our data sets. And I know a couple of people inside of the AI team at Red Hat have already done some interesting analysis on our earlier log files. So we'll have to figure out if we can get you in to do some predictive analysis on OpenShift Online and dedicated sometime. Do you have, besides yourselves, have you seen any success or have any deployments of this platform for other customers of yours, and what has that done for them in terms of cost savings and be able to avoid downtime, or is this still pretty new stuff?
This one is still under development. That we're ready for demo, and I think that the GA general availability will be by end of this year.
Okay, perfect. Maybe just in time for Kubernetes North America and the OpenShift Commons gathering in Seattle. So that would be an interesting time. I think that's yes. December. So that hopefully, I love how the world all revolves around event-driven GA releases. A lot with Red Hat Summit too. So KubeCon is another one, another yeah. event.
Yes.
That helps to incent people to get their GAs out there. But yeah, we're really looking forward to seeing this in action. As I said, we have tons of log files, and I'm sure there's lots of folks out there in OpenShift community that have lots of historical data as well. So it'd be interesting to see what the predictive models look like with some production databases, especially considering all the wide variety of workloads that people are deploying on some of the hosted versions of OpenShift out there. So,
yeah, of course. And if you can make an arrangement, I think that we will place it make the demonstration and presentation in the OpenShift Common Gathering in December. We're happy to do
so. We'll see what we can do. I know the online and the dedicated folks are very busy on the ops side, so it might be something to have a conversation with the AI ML SIG team as well. Maybe we can do some collaboration there. Are there any other questions at the moment? I'm not seeing anyone with too many questions. Paul is asking, can you talk more about disaster recovery planning? And maybe Paul, if you want to unmute yourself, I'll try and unmute you. And have you guys thought, Jeremy and Brian, much about how to use this for disaster recovery?
Not much.
Let me see if I can unmute him and he can call. Paul, you just have to unmute yourself if you want to follow up and maybe clarify what you're looking for. His mic is failing. Well, you have their emails now, Paul, so you can send them an email and follow up directly. He's curious about some of the disaster recovery planning scenarios, and I think that's probably another topic for another briefing, and we'll figure out what we can do for that. But please do reach out to these guys and tell them what your use case and scenarios you're thinking of are. And if anyone else has questions for Jeremy and Brian, you can find them at these two email addresses, or you can find them on the first Friday, usually of every month at 9 a.m. Pacific in the OpenShift Machine Learning special interest group. And if you're interested in joining that, just sign up at commons.openshift.org on scroll down halfway, and you'll find the link to signing up for the machine learning SIG. So with that, Jeremy and Ryan, do you have any final words you want to add?
Yes, we do appreciate this opportunity and talk to this community. And I think our AIOps technology can really help the OpenShift user automate the part resources planning and the automation. So they're looking forward to have that strategic alliance with all OpenShift users. And I know that if we can also leverage your historical data that you collected before in the past 3 years, I think you will be very helpful to improve the accuracy with generated predictions, because accuracy is the best on the big data, and this is the best scenario we can work together in the beginning.
I think there'll probably be some conversations that we have to have about anonymizing all that data and how we do that. But you bring up a good topic: is the more data you have, the better the predictive models. And maybe somewhere down the future, there's a way that we can, all of us who have this information, can start sharing it. And something maybe we could think of doing with the CNCF and collaborating with them to get a shared data source. Would be an interesting topic.
Yeah, we have our email contact information on the slide. So if you the guys have any questions, we are welcome to send your question. We're happy to answer your question.
Well, thank you very much. I'm going to stop the recording, and I will ask you to send me your slides, and we'll continue this conversation in the ML-SIG on the first Friday of every month. All right. Thanks, guys.
Thank you very much.